Hello guys, here Mr. G with another video about the electric circuit for grade 12, but remember this is going to be the last one that it is applicable for grade 10 and 11. This one we're going to be talking about power, electrical energy, and calculating the cost of electricity usage. All this could be asked in the exam for the grade 12 and is also applicable, as I just say, for grade 10 and 11. It's going to be quite short because the concept is not a very difficult one, and then we're going to start by defining power. This is the same definition of power that we did in work, energy, and power. So the power is the rate at which electrical energy is transformed. The only difference is we're using electrical energy, but you can just say energy is transformed or converted in an electrical circuit. Okay, and then the formula, guys, is here. This one is the definition for power, as you can see there. If you go here to the formulas, it is here. This is power. This is power, in which you know the only difference is instead of E is W. So we are going to write it like O W divided by time. W or E, either one is referred to energy or work. So we are going to write it right on this side there, and it's the same here. Can be also work or energy. All right, and you know that the unit for work or energy is the joules, and the symbol is capital J. I'm not going to write the word. Now, in terms of this is time, you know that it is a time, and the unit is the second, is the SI unit for time. And finally, the P is the symbol for power. You know that one. This one is a power, and the unit is a watt. Be careful with the unit here. This one is a watt. Okay, it's the unit for power. Well, guys, this one is just the definition of power and the formula. It is not new for us. We already know that. Here is an important maybe a sentence, which in South Africa most of the appliance operates under the potential difference of 240 volts. And if you go to any appliances in the house and you look around, you will see the power rating. Now, the bigger the power, the more energy it is going to be using that specific appliances, and therefore more electricity, more price you have to pay. It will cost more money to use that appliances for longer time, but we'll go about that one just now. Now, if we rearrange that formula, and note this is just the rearranging of the formula. This is the same formula, but just rearrange it there. You have that energy is equal to power multiplied by time. But instead of that one, let's write this with a W, which is at the end the same thing. I just changing the symbol. So it is here a O. It is the same thing, just rearrange it. In the formulas, in the exam, it is in that specific way of power, definition of power, but note that you can actually rearrange this one. Now, there are other formulas of power when you start substituting different formulas here, which I am not going to do right now. Is not the purpose of this video, but in this case you have different formulas to calculate the power if you have either the potential difference or you have the current. This one here, it is recommended to use it for parallel. Now, note, I say recommended. Please note, write down the note like that. It's recommended. It doesn't mean that it cannot be used in a series circuit. If you know the potential difference, you can use it anywhere. And this other one here is recommended for the series circuit. But now I want you to point out something. All those formulas are here. So all those formulas are for power. You can substitute and use them for power, and obviously it can be also used if you rearrange it for calculating the current, the resistance, or the potential difference. But all those are formulas given to you in the exams. You should not make a mistake in terms of taking the formulas from the exam. Now, if we go here and we substitute each of these formulas, In the formula of energy, let's say we substitute each of them there. We have that, for instance, energy is equal to power, but power is going to be the product of V I multiplied by the time. This is one formula for energy, and I'm doing this one because if you go back to the formulas, guys, these formulas are right here. As you can see, there is energy, and this one that you can see here, we already spoke about that one. What that one was, the definition of potential difference. Let's write it here. Potential difference. Remember, it was potential difference was equal to the work done per unit charge. But now if you say rearrange it, you get this formula, which is in actual fact the one that they're giving you in the exam. But the other ones that are formulas for energy are coming from the combination of each of them, but all of them are given to you guys. If we go here, we say work or energy is equal to power, but power is going to be the square of the potential difference divided by the resistance multiplied by time. And that formula, if we come back here, it is right there. And then the final one, if you substitute here for power into the formula of energy, you get that is equal to I squared multiplied by R multiplied by the time. All those are formulas for energy, and all of them are given to you. I just going to write here, this is for energy or work. Energy or work. All those formulas are given to you, so there should not be a problem for you to substitute or select a specific formula according to the data you have in certain questions. Now, if we go to the last part of the lesson, I say this one is going to be quite short, is the cost of electricity. So how do we calculate how much it costs using a specific appliances at home? And the formula is this one here. Now here I do recommend you to write it down, because it is not going to be given to you in the formulas here of electric circuit. So you won't have this formula of calculating the cost of using a specific appliances at home. For instance, if you're using a computer for 3 hours, how much in rand, in the case of the currency of South Africa, how much it will cost you to use that computer for that hour or 3 hours, or if you boil a kettle or things like that. So this is the formula, and is equal to energy. Remember, this energy that we have here is the same as W. Now, energy of W, guys, if you go there, it is here the way of calculating any of those. And the price here is going to be given by the country that you are at the moment. So in this case, the country set up the price of electricity. It's nothing to do about that. It cannot be changed. In South Africa, for instance, I know different provinces have different prices, so it will be given to you. But now, something important here to have in mind. The price is going to be given by kilowatts, and therefore the energy must be given in a kilowatt per hour, or kilowatt hours. This one is important, and this one is only for calculating the cost of electricity. So you cannot use this unit to calculate energy. Note the unit of energy, if you come here, is joules. Remember, we spoke about joules right there on top, but in this case, joule is equivalent to, if we go here, joule from this formula is equivalent to watt, which is the unit of power, multiplied by second, which is the unit of time. Are you with me? But we cannot use watt in cost. Instead of watt, we are going to use kilowatt, and instead of second, we are going to use time. But that is nothing to change. It's only when you calculate cost of electricity. And let's do this just in case. This kilowatt is coming from the power. That is coming from the power, okay? In which, in calculating the price or the cost, is going to be in kilowatt. And the hours is coming from the time. And there we go. This one is W. Okay, so nothing to worry about. It's quite simple, but it could be a question like this one in the exam to confuse learners because it is something done in grade 11. Okay, now let's look at one very simple example. The purpose is not to complicate our life, but this example was taken from the Sijabolo book, grade 11, and it was in page 411. You can go there and look for the example, which is explained step by step. Now, the question says, how much does it cost to run a 900 watt microwave oven for 2.5 minutes if the cost of electricity is 61.6 cents per kilowatt an hour? So in this question, what do we have? Let's write here data. Remember, I like to write data. Let's see what we have. We know that the power is going to be equal to 900 watt, but we cannot work in watt when we calculate in cost. We have to work in kilowatt. So 900 watt is going to be equal to a 900 divided by 1,000. When you convert it, in this case, it's going to be 0.9 kilowatt. Okay, and then for that time, we have, which is equal to a 2.5 minutes, but we cannot work in minutes, so we have to convert to hour, and is 2.5 divided by 60. When you do that product, you will get that it's 0.0417. I'm going to round it off up until there, and this is hours. Okay, and then the final data we have is the price is given to you, and is 61.6 cents. In this case, they're giving you the price in cents, so the answer that we're going to get is also in cents. Okay, so guys, now we have to write the formula. It's quite simple. The cost is equal to the product of energy. You can write the E, or you can write W, it doesn't matter, multiplied by price. You don't have the energy. What they are giving you is the power, and remember, the power is going to be, or energy is going to be the product of power multiplied by a time. So if we substitute everything there, we can substitute because it's quite simple. We don't have to do two calculations separated. It will be that the cost is equal to power, which is 0.9, multiplied by the time, which is 0.0417, multiplied by the price, which is 61.6. Remember, we're working with cents in this case, so the answer will be in cents. And guys, this one will give you an answer of cost equal to 2.29, no 99, 29 cents. This is the answer. So that is how much it will cost to use that microwave for that 2.5 minutes. It's quite simple. The calculation is not difficult. You can try it. You can do another examples, but this is all. This is all for this lesson or this video on power as well as energy and calculating the cost. Thank you for watching. Thumb up, subscribe for the channel. I'll see you next time. We're going to go then to most definitely internal resistance. Now I'll see you next time. Mr. G here.